No, in Safari.
No Lawrence.
Five more seconds. Okay, so I got 5 responses, and I really like this very expressive one. As many as you need to be happy, very expressive. Okay, so there is no limit. Sky's the limit. Speaking of sky, where does the sky end? Next up, how many classes can a class implement directly? Five more seconds. Okay. Yes, only one. So it looks like everybody got that one right. You can have a chain of classes. But you can only have one direct superclass. Okay. The next question is, why use an interface? And since this one is a more free-form answer, I mean, they're all free-form, but this is a little bit more free than others. I'll give you a minute to answer this one.
I'm still taking up 2 spaces.
Okay, 1 minute is over, and if you're still typing, just wrap it up. But it looks like yeah, I'm just reading through all of them. Obviously, this question is pretty open-ended, so there can be a lot of correct answers. But basically, it's easier to write reusable code. Remember the philosophy of don't repeat yourself. That is implemented by, that philosophy is put into action by using an interface. What's the philosophy of that is? Okay. But also it removes hard constraints on class implementation. So you don't have to remember where does something inherit from something, but obviously you would still need to remember that. It's not as strict. And then also, it also allows for common behavior to be shared among one type of class. So there are a lot of good answers out there. I really like to be more flexible with code that gets the most concise answer award and the most, and then we have a lot of really good detailed responses. They're all very good. And then the most expressive one, I would say, to abstract yourself into oblivion. I like that word choice. Okay. Finally,
that point at the top is pretty important too. That has similar functionality with different classes. So, you probably mentioned that.
finally, is there anything specific that you'd like covered? Anything that wasn't clear? Anything that was not understandable? Just anything about the assignments? And don't be shy, nobody knows what you're writing.
It's anonymous.
Oh gosh, if I knew that.
Maybe we should have a slush fund and get slushies with our slush fund. Or donuts.
This one's just for me.
What?
I have a slushie, but it's just mine.
So if anybody, if you would like donuts every week, you can write as an answer, I would like donuts, and I would like to contribute to a donut fund if you want. Okay. Do number 1 of which assignment? MVC or object oriented? Oh no. Object oriented, okay. So I think that'll be doable to do number 1. I don't know, I don't do the lectures, so we'll see what happens. But yeah, I think donuts are a good idea. But then we all.
Did I not do that?
Maybe not.
Oh, I ran out of
That's not that.
time.
Maybe we should have a fruit platter instead. And I hope that person who said, not the Sprint Accelerator, it's just being funny. It's probably somebody inside here rather than somebody actually at the Sprint Accelerator, but oh no.
Oh, well. Do you guys want? Well, you can grade later. Because we only have limited time before Reggie comes and steals the only HDMI cord we have. So the lecture portion is still over at 7:30 because this will be gone. So I'll go over the assignment. That seems to be the only question. And then I plan to cover cases on why you would use interfaces and an example of an implementation using one. Specifically, it is the eye comparer. So the interface they linked to for you to read the really exciting documentation about. At least I thought it could be pretty exciting. And on Thursday, I actually meant to go over this assignment and show you, but I ran out of time. So the first thing I was going to tell you to do was to search for the word to do. And then you can find, oh, that's funny. I'm pretty sure there are like 11 to-dos in this, or 9. Oh, I even had it already excluding the files I didn't want. All right, I think we can see all the to-dos. Yeah, so you can ignore the one in the .gitignore file because you won't be doing anything with that one. So my first recommendation for the assignment was going to be to search for to-do to get a better idea of what it is you were supposed to do or are supposed to do by Thursday. I failed you on the previous Thursday. So to-do 1, as it states, is to get the job with the given ID and pass it into the view. So what you would use here is to go and get the job by ID, which you'll do on each, where is our model? So we have our job. Jobs have an ID. So in the same way that previously on the other examples we've worked, there have been methods on each one of our view models or a model, depending on which one you choose to put it on, where you would say get by ID, then you would pass the ID to it, and it would return the item you are wishing to get. I would recommend implementing that through the view model. So anytime you need to get data, I recommend going through a view model and letting it go and fetch the data so that you're not ever grabbing that data directly.
So don't put it in the controller, but put it in the view model.
Correct. So the controller, you need to get the job with the given ID and then show it. That separation with the view model, what you would want to do ideally is the view model, you would have some method on there that you would pass the ID to, and you would get a job. That also means you need a view model. Your view model needs then a method to retrieve that job. My cursor. You're not required to use a view model. You could use the model directly if you wanted to. I prefer the view model. Others might do the model. So you cannot. It's not a requirement. Any more questions related to that? I don't want to give away too much. But minimally, you would want to add a method to the model that then gives you the job, and then you would pass the job into your view.
Is there a way to do it with the view model as it's implemented currently, or is that something we would have to?
So with the way it is implemented currently, no, because the view models, there aren't enough of them.
Okay.
You would need to then create your own view model, because generally you have, it may or may not map directly a view model to a model, but sort of the reason that you have view models is they map more directly to your view, and they do whatever work you need with individual models underneath. And the reason for that separation is so that your presentation layer, which in our case is going to be the views, can look exactly how you want it to, but the data points could actually be spread across 7 models, for instance, but you could have one view model that manages all that together. So say you had a profile view for a user, you might have images stored separately to where you store users. And you might have some of that user information, such as their address, not stored in the same place as the user. You might store an address in its own object. And so then at that point you have 3 models, but you could have one view model for profile, and it would know how to, that's awful. It would know how to transfer that data in the user profile view model. That's gonna be bad for everybody. I haven't seen the sun all day, it just comes out now. Let's hide up here. So if you have a user profile page, you can have a user profile view model that would then proxy the address, profile image, username, email address to the 3 different models you might have. So a view model maps very closely to a view, and it may or may not have 1 to n, where n's any number of models. So you could have 1, 2, 3, 5 models that a view model connects to. And that's one of the reasons for that separation, so that you can map sort of the business interaction in your view model and let your models just care about how that data is preserved. Is that actually readable? Oh no, I keep forgetting to switch this. Better?
About everyone else, this is more beautiful, but it's dark for back.
Especially with the sun.
You get dark plus. I don't know how to fix that because there are no shades. Tom, you can just And I do also have the YouTube live dealy. It's only about 30 seconds behind if you're in the room, which is actually kind of terrible because I tried to look at it while someone else was doing it. Are there any other questions about the assignment?
So when you're talking about, the view model wouldn't necessarily correspond to the number of models you have, but we do have a view model for every view, or?
Yes, that is what I would recommend if you're using it, so that the declaration inside of, let's see if this one has one built in for us in these views. Of course it doesn't. The job one should. Well, there's your to-do. You just got to add it in there. There we go. So the new declares one view model to handle everything in that view. That's generally what is sort of done there. That's why there's the one app model declaration. It's also similar for other forms of view model development.
But would it be bad practice to come up with, if you were sort of reusing similar data between 2 different pages that, like we have an index, or, well, actually for a previous example, we have an add page and an edit page where they're gonna look really similar. Would you just use the same view model, or would you actually separate them? Or would you just do it according to what seems right?
You could use the same view model. You could create a class that both those view models inherit from, and then the new page would have a save method, for instance, that the other one does not. So that's another way you could go about it. And I can't see anymore. Yeah, so there is rarely a this is the way you must do it when it comes to writing code, unless you have somewhat of a dictator for a boss when you're programming, and that's less fun. I've had that. I don't anymore. That's why I work where I work now. But you'll rarely find in the wild someone saying, oh no, this is the way you have to do it, or this is the way you must, unless there's very strict guidelines and designs up front, which is rare. When I say designs up front, previously they mentioned those UML diagrams where you would draw your square boxes and you'd say this is the user class and it has a address, and then address is a location for your subs. So you could have all of that. If you work at a place where you write all of that out, then likely you have more formality set up to where there's more of an obvious choice for something. But a lot of places aren't going to care. They're going to care that you write code that can be tested and functionally does what the business needs, if I'm being pragmatic about it.
Well, if you did use the view model, how would you do you actually create an instant of it in the controller, or should you use some by itself? Just wondering how you pass the ID to the view model that it has all the correct data you can access.
So you,
because I actually created a view model object in the controller and had the job object, and then just placed it into the view model, sent the view model to the view.
that would also be fine.
I just wondered if there's a better way to do that, doing all that code inside the controller.
There are probably alternate ways, but I wouldn't say better ways. And I'm less familiar with all of the different ways you can do things in this MVC.NET framework. So in other frameworks, there are very similar ways and very concise ways to like transfer that data to what would be your view model into your view, let it do the work, and it kind of happens behind the scenes. I assume it also has that capability, but I haven't used it enough to know if there are easier ways than declaring the model, passing it to the view model, and passing that whole thing through. So that is a question I can't answer with any certainty. But no one is going to be mad at you if you write code that does that. They're going to go, oh, this works. And if I spent 10 minutes later, I could clean it up, which then 10 minutes doesn't really matter to most anyone when it comes to writing code. All right, I'm gonna hop on over to tonight, which is April. So the example for tonight implements the interface for iCompare. If you're really curious, we can pull up that exciting documentation. It's hidden. It's a little too big. So the iCompare interface, all that it actually implements is a method called compare. It is common practice in many programming languages for interfaces to be very small and not contain a lot of requirements so that you can use them and the objects that implement them more freely in different parts of the system. software that you're writing. So not only does it allow for greater reuse, with interfaces having fewer methods, it makes it a lot easier for people writing libraries to say, oh, you just need to implement this one tiny little interface instead of a very large one. Because you could see, for this comparer one, it needing a lot more than just one method that compares them and returns an integer. Yeah. So it returns an integer, and it takes two objects. And since all subclasses are, let's switch these, inherit from object, and sort of any type you put in there is all right because they are all objects. So you can be more specific and it will still honor that interface of two objects being compared. Now what you should do whenever you go to compare two objects, so you do go to write it, you should be very explicit about what you're expecting. And in the example I'm going to show, what I have implemented is a comparer for area. So in the example, I think this shows the example. This isn't what I wanted. There we go. So the iComparer interface here, what this example does is it goes and implements it, and it compares, I believe, squares or boxes. And then whichever box is the largest box when you're sorting will be the highest in the list of boxes. What I have implemented, and the reason for it, is area of shapes. So I've also showing an example, I'll go into it in a second, using an abstract class, because we hadn't had an example yet, in my opinion, that showed a realistic case for why you would ever implement an abstract class. And if you imagine you were writing software for an architecture agency that was trying to design rooms or furniture, and you need to get the area of the rooms or the furniture you're building to know which ones are largest, or if you're taking inventory of the items you have, you might want to sort them by the area they take up. So that is why I have made an interface that takes up area, that measures area. And then shapes, but not a lot of shapes because I'm lazy. So just a few shapes. That's sort of the reason that I thought about using shapes, and an actual reason people would use them are for architectural style programs. Have you ever heard of CAD software? They use a much more complex version of the sorts of things that I'm going to show. So I'll show the program. Where'd my terminal go? It's not a very exciting program. So there's a triangle, a circle, and a square. I've hard-coded their values this time, mainly because I wanted to consistently show that the sort order works. Which in this case, you started off triangle, circle, square. The triangle has the least amount of area, but it's showing up first. So then I sort them, and the triangle comes out last. The reason that you would want an interface in this case so that you're not having to go and implement, oh, how does a triangle compare to a circle? How does a triangle compare to a square? How does a square compare to a circle? The advantage to an interface in this case is that they can all implement a method, area, and then you can compare that value. And then to take it a step further, that's why that's then why I've gone and created an comparer interface so that you can sort them without having to do a bunch of constant checking each time you want to do sorting. I went away from my notes. So the program, not very exciting in what it does. Close this. It goes, we create a circle, a square, and a triangle. There are actually impossible triangles, and I didn't bother to write the code to determine if it's not, but I do know you can write equal length side triangles. So I know that that is correct. That equilateral triangle is safe. So the first thing you'll notice here is I went and put the shapes into a list, but the type of the shapes in that list is I area, which means they're not actually all that same. They're all different shapes, but to the list, they're just an I area object. Sounded like that awesome pinball game that was on my old computer. So then we list the shapes at the start, we print them, which I'll show you the print because the print actually takes advantage of the abstract class that I've not shown you yet. And then the sort happens. And this sort here is actually a fairly common pattern in object-oriented languages where you define sort of your sorter. Or in our case, what I called area first, it's the I comparer, the thing that implements the I comparer. It's basically a class that just says, this is how we're going to sort this stuff. So I've written this for similar but different programming language. At work, we do a lot with invoices, and I've written very similar code to sort invoices because we sort them based on how much they'll earn if they're paid early and how much money they are. So we take multiple values of those invoices and then sort them. And we might also change how we do it over time. So it's very helpful to just be able to go in here and say, all right, I have a list of stuff, sort it, and this is how I want you to sort it. The sort of sorter object is how I want to sort. So in our case at work, we actually have like 6 different ways we might sort invoices to decide how we're going to use different groups. The same idea, you've got multiple ways that you might want to sort shapes. I'm choosing to only sort them by area first, so whichever one has the greatest area, but you might want to sort by whichever ones have the most sides, whichever ones have the least area, whichever ones have the most area within a limit. So you could get more specific. So say you only have a certain amount of space, but you want to fill it with the largest shapes first, then you could have your sort of do a little bit more there in the way that it does comparing. And then because I like spacing, I just wrote a new line character. Then we print it again. Then I wrote this print shapes for loop that then goes and prints them. You can't tell here, but they all print the same because they are all of the same subclass. So they're all separate classes, but they all print it out the exact same. So over here, we have our shapes. Apparently, oh wait, no, that's my little hand cursor. So we have shape, which is our base class. I'm not showing the implementation yet. Then we have square, circle, and triangle, which are our various shapes. And then we have area first, which isn't actually a shape. I just sort of jammed it in here because it was for comparing. But if you notice, you are allowed to go, much like we have in the MVC, you can sort of, as long as you give your classes the proper namespace, You can sort of nest them anywhere within your project directory structure. So we can look at the shape class first. So it's in the namespace for this little program here. It's an abstract class, which means you cannot just create a shape. Because you can't just generically make a shape. All shapes fall into some kind of definition, not just shape. So you're not allowed to only implement shape. However, if you're going to make a shape, it must implement an area class, not an area class, an area method that returns a double, which we'll see is also a requirement of our iArea interface. And then right here, this public override string to string, this is why it's an abstract class. It's because I'm actually providing some implementation, the implementation being to string, and that's why it's able to list out the type of shape and then the area of that shape. And it's safe to do because we require all subclasses to implement the area method. So then we can call area inside of our string, what's that called? Our interpolated string there. Then it will just show up, as you see here. Now I mentioned that the area, one of the reasons it's in this base class is it's required in order for us to print out. But not so coincidentally, we have an interface that's very simple called area. Well, iArea to indicate that it is an interface. And it is used so that we can do our sorting. So area, oh wait, I opened that on the wrong one. So inside area first, if we look back at the documentation for iComparer is an interface. And what that T, you'll see this in a lot of places when you look at interfaces, or even when you look at some classes. The T just says insert some type here. And you get to define that type. So in our case, we're saying that we're going to create a class called area first that implements the iComparer interface for iArea. And the reason that we explicitly say iArea is because we want to be able to do the comparison of different shapes with area. And if we didn't implement iArea, we wouldn't be able to ensure that we can call area when we're comparing them. And the reason that I do the second one is because I want it to come first. I want the bigger one to come first. And the compare to, well, if this screen were larger, let's see. So you can read all of that, but it more or less boils down to compare to the second one is done first. So if you do the second one compared to the first one, then the larger will come first. Larger value will be sorted first in your list. If you do it the other way, it comes to the bottom. And I found that out because I had it in the other order at first. Not because I read that. I was too lazy to read that. It was much faster to just switch them around. So this area first, so it says there's one reference. It is what we use to sort all of our shapes. And the reason we're able to sort all of our shapes is because they all implement that iArea interface. So the circle shape is the simplest one. So the circle shape inherits from shape and implements the eye area interface. The reason it implements eye area is so that it can be sorted later. So circles have a radius. I just made a constructor method that would go and set it. Then we override the area function method. The area method of our super shape class, it's actually required for both our superclass shape as well as the interface. And that returns the area of a circle, which in our case would be pi r squared, but I just chose to multiply the radius twice. Yeah. And then the same is true for each one. Feel free, if you have any questions or anything is unclear, to interrupt me. Or you can just bang on the table. So then here's square. Also fairly simple in implementation. So it also inherits from shape, implements the eye area interface so that the sorting can happen. And then the area method, in this case, is side times side. So length times width, you get the area of your square. In order to be a square, your sides have to all be the same length, which is why I only accept one parameter in the constructor. That's the same sort of thing to keep in mind when you do create classes. If you can make your class smaller, because you can make assumptions based on input you're given, you should favor that. In the same way, if I were storing this in a database and I had a square, I wouldn't want to store the length of each side of the square, because I know a square, all sides are the same length. So if you think about those sorts of things when you do go and create code and database schemas, keep that in mind. If you can derive a value based on what you already have, if it is not time consuming to derive it, then you should probably derive that value most of the time. And the key to all of the shape classes is the way they compute their area is all different. And that's one of the reasons we wanted that interface, is so that we know we have the same area. We have the same method that we can use on all of our shapes to compare them and then sort them later. And then finally, triangle. Triangles have three sides. If I wanted to be proper about it in the constructor, I would raise an exception if it wasn't a valid triangle. I was too lazy to look that formula up. So you can create invalid triangles here. And then I stole this formula for determining the area from the internet. Don't worry about this formula. It was terrible. All that matters is it also has a method that determines the area of a triangle. Suppose if this has a negative value is how you know that it's not a valid triangle. Unrelated. So we've covered all that. If we go back to the main program, the goal of the program was to figure out which of our shapes was largest and put them in order. If we created hundreds or thousands of shapes, you wouldn't want to sort them by hand, and you also wouldn't want to have to create if checks for each type of shape. So if I went and created shapes all the way up to a dodecahedron with 20 sides, that would be pretty annoying. Is that 12 sides? I think it's 20. Oh well. It's 12 or 20. They're close. But if you have a bunch of different shapes, different sizes, and you don't actually know the shapes you're going to get up front, so for instance, in a CAD program, you let people create sort of generic shapes in the area they're going to take up. You don't know that up front, but you do know if you wanted to sort them, you could actually provide a way to sort them because they'd all implement that area interface. Are there any questions on interfaces? What's here? What is unclear?
Exercise question 1 was all of these which we list versus I list, and also documentation is out. But we can try to find the ones that images I list. It's in the scenario where you list a never use list. Is there a situation where you use list over I list?
Again?
Yeah, basically, what I found was that there is never a reason to use list over I list.
Well, you would use a list if you were just using a list directly. Are you saying if you're implementing your own type?
I don't have the
Oh, I'll pull up that question.
one reference to.
I remember. I'll zoom in again.
Everything I read was the advantages of I list over list. That's how I was wondering.
Oh, I see what it's saying. This specific question is saying between iList and list, this specific one is basically what does list already have baked into it that iList does not? Which you can sort of argue you can implement, like actually use it directly. But the main thing here is the iList interface. The only requirement are the 2, 4, 6, 8, 9 methods. And if you knew in your code, so what that question is getting at is if you were taking a list of arbitrary things, when would you say I want a list of arbitrary things or I want an iList of arbitrary things? So in the example, sort of what I have here, if I were to, down below, I say that I take a list of I area. My code will actually still run, and probably what I should have done was I list area, which runs and it's fine because I'm not using any of the features of lists that are not a part of iList. So what this question is getting at is if you were, so sort of this little print method that I made, when are cases that I would want this to be list of I area instead of I list of I area? And those cases would be anytime. So right here, there's a binary search method that you get for free on a list. So if I wanted to traverse or search through a list in a specific way. So if I wanted to say what item is in a list, I can go and call these fancier ways of finding items in a list. So here you can go and do an index of, and find it, and it will return that index. But it will start at index 0 and work its way all the way through. Whereas what this binary search will go and do is it will break the list in half and then search each one in a smaller space and then break them in half again. And we'll keep doing that until it finds, which then takes half the amount of time to find an item in the list. So if you were taking advantage,
It's in half, doesn't it?
yeah, it keeps splitting it in half. So copy to is why it actually implements the other one. This exists on here. Yeah, so this doesn't have exists as well. So if you were just checking to see if something existed on your list, then you could check here. I believe list implements what's required for the link. So that link, what's that called? Language something, language integrated query. Link thing to let us write the fancy select from, you could choose with those link queries. List implements that interface, that link interface. iList does not. So if you were using link, that's another reason you would say, oh, I need someone to pass a list instead of an iList. So those are cases where you would use that concrete type of list over the interface iList. But if your implementation only requires, so over here, where I was using list before, that was overly restrictive. And you want any code you're writing that is reusable to be as least restrictive as possible. So that's the reason we created that iArea interface, is then we can sort of create anything that has an area, we now can sort it. So more than just shapes have area. I mean, everything technically is a shape, but other objects could have shapes. Other objects could have area. Other objects in our system could have area. If we just created a table, it would possibly have an area. And we could sort it with all of our circles and squares. That same idea here in my print shapes, I would use iList because it's far less restrictive on what it can take in. Because I don't actually have to have a list, I just have to have something that implements these 8 methods instead of a list that implements these like 40 methods. And in that case, because it is actually a concrete type, a class list, it's more restrictive than just implementing these methods. It must be a list. So that person would then have to be subclassing list or passing us a list directly. Whereas if we say iList, as long as what they pass us implements those methods and they've said it implements iList, then we can use it. So you do have to specify. So we created the circle here. When you create your class, you must specify which interfaces you are purposefully implementing. And the reason that is required is when your code compiles. So the difference between Python and C# largely is that C# is a compiled language. What it does when it compiles down, it knows whenever it goes and makes this into what is the machine readable code, so what the computer reads directly at the CPU level, it is able to communicate that anything that's called circle, you're safe to call area on it because I know that it implements iArea. I know that it is a subclass of shape. If you don't specify that it implements iArea, anywhere that you're requiring that iArea interface, you won't be able to use the circle because it doesn't specify that it implements it. That can be a little annoying. You would think, oh, it implements the area class, so it should automatically fulfill that. But the language requires you to be explicit. That is one of the differences between C# and some of the other strongly typed languages. Some other ones will do what's called inferring, and they'll infer if you meet an interface or not. And they're able to do that because their compilers do extra work to determine that when it compiles your code down. C# does not do that extra work, to my knowledge. So you have to specify every time, all right, my circle, implement the iArea interface. But to get back to the original question, you would choose list over iList if you actually wanted to use sort of any one of these methods that is not part of the iList. So for example, reverse, which is a pretty common thing to do. List implements a reverse, we'll flop it around. One of the big advantages if you are using these built-in data structures, like the list, instead of implementing it yourself, is oftentimes it has gone through the work to, as of its creation time, use the most efficient algorithm for doing things like reversing the list or searching for an item in it. Searching for an item, though, is a little bit, depending on how your data is sorted, some searches are better than others, which is why it gives you different types of searches, because you know how your data is sorted, so then you can take advantage of the different types of searches available to you that are built in onto the list. I think technically, all I need in the program, enumerable. It could be even less explicit. So all I'm doing is that for each. I was actually going to show an example where I made a little container class that did enumerable, and then I realized I'm not sufficiently skilled at C# to do that in a short period of time. So you got an iComparer example. Are there any other questions? Sort of the goal for tonight, why you will have a little bit more time, is so you can work on the assignment that is due Thursday, and any assignments you do not have turned in, because there are more than 15 of us, and there's only 15 of us that have turned in most of the assignments to today. So as a note, this is mostly from Sally and a little bit from me. You should turn in your assignments or get them done as soon as you can. Thursday's one's fine to get done then, but if you don't have other ones done yet, you are encouraged to do them. And if you have questions about them, we're happy to help out. Are there any other questions before we break out into, I have to show you the studio. That's what happens when I don't have the notes in front of me. You can still ask questions. Wait, I thought there's a city studio tonight. Yes. I want to make, yeah, that's right. I left it out of my notes for some reason. Yeah, that is tonight. So there's a cities studio. I don't want to start on this if anyone has any questions, so I don't want to leave anyone out that might have questions, or if you don't feel comfortable, you can post this answer over here. You post your question there. And then no one will know, except I'll watch you on your keyboard, and I'll know. You'll be the only one typing. Ooh, use the read in data. Why am I not opening that? So there's some pre-code for you already for tonight's studio. You can find it there on GitHub. I've spoiled it a little bit because I implemented an iComparer interface for you, but you get to do that tonight yourself with cities, and you'll get to compare two cities and decide how they sort. And you'll actually have multiple sorts that you will create. Let me get you down. Your task that you've accepted because you're really excited about it. So you have a state comparer, so alphabet, population, and land area. So a lot of different ways you would sort states or cities. In this case, cities by the state that they are in. And then it mentions putting them in a comparers folder, which is a much better location than I did, just jamming it there in the shapes folder. And then if you want to get really fancy, you can implement further comparers. Unrelated to this assignment, but overall related, everywhere you're seeing that T, if you're curious about the overall concept and want to read about it, it's referred to as generics. And that is a fairly complex topic. If you want to go and dive into it, you are welcome to. If you have any questions, I'm happy to help you out. But we're not going to cover it at all in the next 3 classes. I just wanted you to be aware of the term used for that is generics. And one of the reasons it is so powerful is that T is a variable and it allows you to specify that any type can be given there. So it's not that it's only parameterized. You can also create your own classes that do that if you wanted to. So if I wanted to be, where'd it go? If I wanted, I could go and implement something like that. What happens at this point when you go and use that variable T, that allows you to then use that same variable anywhere else. So then I could, in my area, I could say it returns T. You notice there's no errors here. That is what the generics are getting after. And that's what all this documentation, so if you look at list, you define it, it goes and says index of T. That's whatever type you defined. And the actual implementation of index, that's all implementation of list. All it says for that method is that it takes a parameter of type that you specified. And then it goes and finds it inside of the container. That overarching concept, if you want to look into it, like I mentioned, is generics. That is as much detail as I will give for now, unless someone's super curious. I'll warn you, I can only go a little bit deeper on the subject matter in a way that won't be babbling. All right, any questions on the studio before we get started? And if you don't like this room or there's too many people in here or you don't like us, you can also use the room behind us as they moved. So you're free to also move over there if this is too many people or you're too close. Feel like you're trapped. Remember to work together in groups of at least 2. Find your buddy. Write your studio code. And if you have questions about your assignment, let us do. We're also happy to help out with that.
So well.